Hello everyone. In this video, we're going to be taking a look at L'Hopital's rule. L'Hopital's rule is a theorem that gives us a way to find the limit of a function that is in indeterminate form. So just to start off with, let's talk through a couple pieces to this rule. So the first thing, let's say we want to find a limit as x approaches some number c. And let's take a look at a fraction f of x divided by g of x. Now, in indeterminate form, what that means is if I try to find the limit of this function, if I end up with something such as 0 over 0, or if I end up with infinity divided by infinity, these are what we call indeterminate forms. These expressions can't be calculated. We know we can't divide by 0. And infinity, it's not a number. So infinity divided by itself, that doesn't give us 1. We actually don't know what that is. So we need a different way to evaluate these limits. And that's where L'Hopital's rule comes in. So L'Hopital's rule, what this says is if I end up with an indeterminate form of 0 over 0, or infinity over infinity, instead of taking the limit the normal way, I can actually find the limit by looking at the derivatives of the numerator and denominator. So what we end up with is if I have the limit as x approaches some number c of the derivative of f divided by the derivative of g, if I can find that, and that equals some number, so we get some finite number, which I'm just calling L, then our original limit, so the limit as x approaches c of our original function, is also going to be equal to L. So if I take a look and I see that I can't find the limit just by using what I'm given, because I end up with an indeterminate form, I can take the derivative of the numerator and denominator, find the limit of that expression, and that's going to be the same as the original limit. So let's take a look at a couple examples and just talk through this process. All right, so here's my first example. I have the limit as x approaches 0 of the tangent of x divided by 6x. So just over here as a note, if I try to find this limit just by plugging in 0, I would end up with the tangent of 0 divided by 6 times 0. The tangent of 0 is 0, and then we know 6 times 0 gives me 0 as well. So I do have an indeterminate form, 0 over 0. So that means that we have to use L'Hopital's rule to find the limit of this. So what we're going to do, we're going to take the derivative of the numerator and the denominator. So we'll take the derivative of the tangent of x. That is equal to the secant squared of x. And then let's also take the derivative of the denominator. So the derivative of 6x, this is just the power rule, we end up with just 6. So this original limit, that's going to be the same as the limit as x approaches 0 of the secant squared of x divided by 6. So now I'm using the derivatives to help me find my limit. So now, to find the limit, here we can plug in 0. So we get the secant squared of 0 divided by 6. Secant of 0 is equal to 1. 1 squared is just 1. So we end up with a limit of 1/6. So now we don't have an indeterminate form. We're able to find an actual number that this expression is approaching. So that means that our original limit of the tangent of x divided by 6x as x approaches 0, this is equal to 1/6. Let's take a look at one more example just to talk through that process again. So the second one, the limit as x approaches infinity of the natural log of x divided by x. And again, just as a note here, if I were to plug in infinity, I can't really plug in infinity because it's not a number, but as we become unbounded, the natural log, as my numbers keep getting bigger and bigger, the natural log also increases without bound. And then in the denominator, that is also going to increase without bound. So we do end up with this indeterminate form of infinity over infinity. Again, that means we need to use something else to find this limit, and that's where L'Hopital's rule comes in. So we'll take the derivative of the numerator and the denominator. So the derivative of the natural log is 1 over x. And then the derivative of x, this is just equal to 1. So now taking the derivatives, that original limit is going to be the same as the limit as x approaches infinity of 1 over x. That would be my new numerator. And then this would be just divided by 1. But dividing by 1, that doesn't do anything, so I'm not going to write that in. So now we don't have an indeterminate form, which means that we can evaluate this limit. So as x becomes unbounded, so as these x values get larger and larger, this expression is going to approach 0. So that means that my original limit is also equal to 0. And that's how we use L'Hopital's rule. So the first thing, if you take a look at your limit and you see that you have an indeterminate form of either 0 over 0 or infinity over infinity, we know we have to use L'Hopital's rule. Take the derivative of the numerator and the derivative of the denominator, use those to find the limit, and that ends up being the same as our original limit.